I'll start by introducing my topic by saying the phrase, boys will be boys. This phrase has been used to excuse the behavior of men for thousands of years, and although this phrase seems like a way of saying that boys are the more rambunctious gender, the phrase has a contrasting connotation that makes a once playful statement into a justification for the undesirable persona a man takes on in the household where man is king. The man of the house mentality has been relevant since society became civilized, and by studying the genres of Roman comedy and the traditional Mexican telenovela, it is possible to substantiate the similarities between men of ancient Rome and Mexican men through their respective archives in these genres. So, how do male figures appear in scripted works? Well, in Roman comedy, the paterfamilias, the most respected man of the household, and his family is the brunt of all jokes. In telenovelas, the male characters are represented in a way that male audience members wish society would see them. They're flawless, handsome, and heroic characters who the audience is meant to root for. The treatment they receive is proportional to the real-life difficulty of his job as well. For example, someone who is a hard-working farmer might be the star of the telenovela because he has the hardest job and he should be treated as the hero of the story. While the Senex character of a Roman comedy lays all of its flaws out on the table, the telenovela man hides his flaws behind layers. When stripped of these layers, it becomes evident that these character types are more similar than they seem. Both characters demonstrate an entitlement towards other characters that reinforce their positions of privilege within the family unit.
Welcome everyone, and thank you for coming. I am sitting here modestly asking for only your ear. My name is Casina, and you may find it a little strange that I'm sitting here and talking to all of you like this, but I promise, I am doing it for a good reason. And on this stage, you'll find that my words are minimal compared to those around.
Hi, I'm Gina Drace. I'm a senior in computer science, and like was mentioned, I created a video game called The Great Escape. I almost minored in art, so this project gave me an opportunity to use my creativity in addition to my computer science background. So the first step was to make a physical prototype, and this is kind of unusual for a whole video game. So I wanted to share some pictures because this was my first step in actually designing the virtual environment for the first level of the game. So that prototype eventually turned into this. I spent a lot of time on this level because I really wanted to create a fun and playful environment. Since the player is a toy car, I wanted them to really be immersed in this kid's room world for the start of the game. So the task of collecting blocks is not that difficult, but I wanted the player to take the time to explore the environment and get used to the perspective of the toy car. If it is knocked down, the sound triggers someone walking into the room, and when the person walks in, they leave the door open, so the player is allowed to make their escape. And this time, sorry for that kind of loud sound, they're successful and they broke through the door. And then we're brought to this ending scene that's pretty similar to the starting scene. But, it's later in the day, sunset, to create the illusion that some time has passed since the start of the game.
So hi, my name is Teresa, and I'm a researcher at Murphy Lab UIC, and my capstone was done with the support of Brian Murphy and Jung-Ho Lee. My capstone project is titled Drug Discovery, Structure Elucidation Using Nuclear Magnetic Resonance Spectroscopy. I understand that is a lot to take in at first, but we are going to break it down into 3 parts: drug discovery, structure elucidation, and nuclear magnetic resonance spectroscopy. And with that, let's begin. Drug discovery is a process of identifying new prescriptive medicine, where a majority are isolated from nature. In the last 30 years, 50% of approved drugs have been isolated from natural product. In this figure, which is a pie chart of all small molecule approved drugs in the last 40 years, you can see that more than half of the drugs are from natural product or are mimicking a natural product. So, with knowing that a lot of drugs come from natural products, this leads us into structure elucidation. Structure elucidation is a part of the natural product drug discovery process, and natural products come from all around us. But it's hard to look at, a sponge and know exactly how many carbons, how many hydrogens, how many oxygens it's made of, and how those are connected. And so the main problem here is that the structure of these natural products are unknown and we need to elucidate them. To help me further explain why obtaining these structures is important, let's take a look at penicillin.
So my project is on a field of mathematics called Galois theory, and this is pretty theoretical math coming up, so I apologize for that ahead of time. In order to get to Galois theory, we start off by asking questions about polynomials. And polynomials are very important to mathematics because approximation via polynomials is a rich subject of study, and there are higher algebraic fields of math that require this sort of concrete knowledge. What I mean by a polynomial is this. It is a finite sum of terms. Some of the factors are variables. And we say that this polynomial is defined over a field if all of the A terms are in that field.
I have a general question. So your last statement was that it's an extremely rich and versatile theory. So what other things can it do that you would find really interesting?
So I was like, last night I was dreaming that someone would ask this question. And it's kind of hard to appreciate how much Galois theory can do unless you're like pretty deep into math or applied math or something like that. But for example, I'm interested in number theory. It's virtually impossible to do the kind of number theory I'm doing, even as an undergrad at this point, without Galois theory. You could do it, but it wouldn't be nearly as interesting probably. The other thing that you can apply it to that's really nice is it's extremely important for understanding stuff like elliptical curve cryptography from the ground up. You might not need it as like a CS person doing it, but if you want to understand the theory in full generality, you must understand Galois theory.
So good afternoon, everybody. My name is Olivia Lee, as Julio introduced me, and I will be presenting about community gardening in Englewood and what it tells us about the meaning of well-being. Just so you know, this project was done as a part of the Cultivating Wellbeing project led by Dr. Molly Dillon and the Anthropology Department. So this table was taken from Chicago Metropolitan Agency for Planning, and it shows the stark contrast between Englewood and the rest of the city. So in Englewood, its median household income is 2.5 times lower than the city average. Only 7% of its people have bachelor's degrees or higher, and 35% of the housing units are vacant. And community gardens that exist today are made to be, as this gardener says, communal places where people feel loved, safe, respected, accepted, and free to be themselves. Sometimes community gardens are literally in the middle of deteriorating landscape. So in the first photo, the house to the right has been abandoned for many, many years, and the garden leader hasn't been able to track who was responsible for it, so it has been sitting there for a while. And then the red building to the left is an elementary school that was permanently closed, but then the garden is between them. And there's a lot of vegetables that are being produced and distributed among the community members.
Hello, everyone. Good morning. Today I'll be presenting on racial and ethnic trends within the geosciences at UIC. And this is really specific to me and special to me, just because as a Black woman in STEM who's like transferred from a biology major to an EAS major, it's just something that I've seen a lot in the experience. So this research is very hands-on, but also specific to my experiences as well. Yeah, that's basically what sparked this research in the first place, just kind of experiencing that firsthand of seeing kind of like a lack of diversity, not just specifically for Black women as myself, but just in general. So as you can see, the STEM graduate level, like degrees versus like bachelor's degrees, you can see there's a difference between how that's distributed between minority groups. And STEM as a whole has been making really great progress in distributing that more evenly, but you can still see that there's a gap between some racial groups such as white and Asian American compared to more underrepresented groups like Black, Hispanic, and Native American. And compared to other STEM sciences, the geosciences also tends to fall behind by a lot actually, but they're still making that same consistent growth. It's just that compared to other STEM sciences, they do fall behind by at least a few percentages. And compared to the US population as well, there is a gap between those underrepresented groups that are represented through STEM bachelor's degrees versus the population as a whole.